Everyone, so we're looking at class 18. I'm not going to work through this one with you. I'm just going to kind of talk you through it. So our goal is to, given the initial velocity of a projectile and time elapsed, find the height, velocity, and acceleration. So we have problem one and problem two here. And what we'll see is these problems are actually two sides of the same problem. Problem one says a ball is launched with an initial velocity of 5 meters per second. What is its max height? So its initial position is down here. Its final position is up here. Its initial velocity is 5 meters per second upward. Its final velocity at the max height, as we said last class, was 0. Okay, the other piece of information we have is that the acceleration is negative 9.8 meters per second squared. Why is it negative? Because it's hurting or slowing down the initial velocity. We're looking for d. How high did it go? So we don't have time, so we can use vf squared equals vi squared plus 2ad. And we get that the max height is 1.2755 meters. Make sure you're able to work that out on your own and do that from scratch. Now the next question, this might look a little familiar. The ball is now dropped from a height of 1.2755 meters. Okay, so it's dropped from the same height that this one reached. So it's a different question altogether. So the initial velocity, since it's dropped, is 0 meters per second. The acceleration is positive 9.8 meters per second squared. Why is it positive now? Because we're dropping it. So the initial direction of motion is down. The acceleration is therefore helping the initial direction of motion, right? It's falling 1.2755 meters, and the final velocity is what we're looking for. All right, so we still don't have time. So we do vf squared equals vi squared plus 2ad, and we get a final velocity of 5 meters per second. Okay, notice how we basically just did the same problem, but forwards and then in reverse. Okay, this is typical. If we throw a ball up with a velocity of 5 meters per second, it goes up to its highest point, and by the time it reaches the height it was thrown at, when it comes back down, it's going 5 meters per second again. Okay, so this question we basically look at two sides of the same question. So if I throw an object up with an initial velocity of 10 meters per second, it slows down on its way up till it hits 0, and then speeds up on the way down, and when I catch it at the same height I threw it from, it's going 10 meters per second. All right. So again, make sure you're able to do these two questions on your own without looking at any help here. So number 3 says this brings up a really important point. I just mentioned this. We're effectively looking at two halves of the same problem. We can conclude that if a ball is thrown straight up with a speed of 19.6 meters per second, the instant before it lands, it has a speed of 19.6 meters per second, or a velocity of 19.6 meters per second. Really important idea. Downward, downward. That's important. All right. All right. Looking at this one here, it says a ball is thrown straight upward from the surface of the Earth. Which statement best describes the ball's velocity and acceleration at the top of its flight? Well, we know the velocity at the top of its flight is 0. We know the acceleration at the top of its flight, the whole time during flight, is 9.8 meters per second squared downward. Okay, so the only answer choice that's left that we could use is velocity is 0 and acceleration is non-zero, meaning any number that isn't 0. All right. All right. This one says here, a ball is hit straight up with an initial speed of 28 meters per second. What is the speed of the ball 2.2 seconds after it's hit? So we have the initial velocity, 28 meters per second. We don't know the final velocity. That's our unknown. We don't know if it reaches the highest point yet. We know the time is 2.2 seconds. We know the acceleration is negative 9.8 meters per second squared because it is hurting or slowing down the initial velocity. So looking for V final. We don't have D, so this is the one equation that does not have D in it. VF equals VI plus AT. We find that VF is 6.4 meters per second. Now, one really important thing here is that it's positive 6.4 meters per second. So that means it's still going up. Okay, so after 2.2 seconds, it's still going upward. Okay, it hasn't started coming back down yet. Now the back page here, there's a lot of stuff going on in this back page, so let me just kind of walk you through it. Basically, a ball is thrown up with an initial velocity of 19.6 meters per second, and it has an acceleration of negative 9.8 meters per second squared. All right. So at time 0, height 0. So what we're doing is we're figuring out, okay, what is the velocity and height of the ball after each second goes by? So after 1 second goes by, let's see, we have VF equals VI plus AT. V initial, you're always going to refer to this point as V initial. Always, always, always for all of these. So the initial velocity is positive 19.6 meters per second. The acceleration is negative 9.8 meters per second squared. Now, last students came up with a great question. They said, on the way down, though, shouldn't the acceleration be positive? No. Okay, you always refer to your initial velocity when determining whether your acceleration is positive or negative. Okay, since the initial velocity in this case that we are choosing to be our initial position is positive 19.6 upward, the acceleration is negative because it is hurting it. Okay, please be consistent with that. The only time you can make the acceleration positive is when the ball starts up here. You call the initial velocity 0 and it's coming down, or if the ball starts up here and you throw it downward and you call the initial velocity positive because it's going downward, then you can make acceleration positive. But please stay consistent. We're always referring to this point, point 1, as the initial position. Okay, so when you're like solving for point 4 here, you're pretending points 2 and 3 and 5 do not exist. Okay, this is initial, this is final, period. You're solving for point 5, this is initial, point 1, this is final, point 5. That's it. All right. So, the answers are pretty much all there for you. There's really not a lot for me to say aside from, for this first one, initial velocity is from point 1, acceleration is negative 9.8, and t is 1. And you can solve through for the velocity and so on. Again, for here, the initial velocity is still 19.6, the acceleration is still negative 9.8. Here, the initial velocity is 19.6, the acceleration is still negative 9.8, and time is just 3 now. All right, and for this one here, the only difference now is that time is 4. Notice the symmetry in this question. Notice points 1 and 5. They have the exact same velocity, but one is positive, one is negative. Same acceleration the whole time, same height. Look here, at the same height, both at 14.7, they have the exact same velocity in opposite directions. And at the top, we expect the velocity to be 0, okay? One thing I didn't quite draw in this, and I don't have my pen hooked up, so I can't really show you too well right now, is that the acceleration is pointing down for all of these, okay? So the acceleration A points down here. The acceleration points down here. The acceleration points down here. And all those acceleration arrows should be about the same size. Okay, now the velocity, well, the velocity vectors I drew, velocity should be getting smaller on the way up and 0 at the top. Now on the way down, the velocity vector should be the same size but opposite directions. So this would be like the velocity vector, about the same size as the velocity vector across from it, but down. And here the velocity vector should be the same size as the one across from it, but much bigger, something like that. All right. So there you have it. This was class number, what was that, 18? All right, let me know if you have any questions. Sorry, I kind of breezed through it real quick.